Hello everyone and welcome back to the JCE Connect. So I am Naresh Patil and today here to discuss about or to discuss over subject design of steel structure. Okay. So in the last session we have discussed about the lug angle, design of lug angle, and what are the importance of lug angle, what are the importance to provide lug angle in tension member. So that was the last session for design of tension member. So after that, in this session we are going to cover the next part, that is column basis. Okay, so this is again the part of the fourth module. Okay, this is the last part of the fourth module, column base. So what do you mean by column basis? So column basis is nothing but the foundation of the column. In case of steel structure, it is called as column base. It is nothing but the foundation provided below the column. Okay, so column base are structural elements used in the design of steel structure to transfer the column load to the footings. Okay, so as I told you, it is nothing but a structural element which is called, we can call it as a foundation. Okay, used in design of steel structures to transfer the column load to the footing. Steel columns are normally supported over concrete blocks. However, when the loads supported by these columns are large and the bearing pressure of concrete from below is insufficient to resist the loads, they may fail. Therefore, it is a normal practice to distribute the column loads to the two steel base plate which are placed over these concrete blocks. So generally how we used to transfer the load? Through column the load will be transferred to foundation, and from the foundation the load will used to transfer to soil. So here, if the column, in case of steel structure, the column is directly rested over the pedestal or the concrete footing. So because of the high bearing pressure, the column, the foundation may fail. So to overcome that, in steel structure, below the column or at the end of the column, one plate will be provided, which is a base plate, to transfer the or to distribute the load safely to the pedestal and from pedestal to the soil. Okay, and you can see here, okay, small sketch over the column base, and this we can see this is a plate provided, plate, and over that plate a column is resting. Okay, and that column is resting through over this plate, and the load will be transferred to the pedestal or the concrete footing. See, you can see this is a concrete footing and this is a base plate and a column. Okay, so you can easily transfer the load through this column to this concrete pedestal safely by using this base plate. Okay, so you can see the elements here. This is a concrete footing, this is a base plate, and this is a column. Okay, so you can easily transfer the load to the pedestal, concrete pedestal, through the base plate, and that load will be transferred safely to the soil. Okay, so next is the types of column bases. So there are two types of column bases basically. One is slab base, one more is gazetted base. Slab base and gazetted base. I'll brief out about the figure here once again. Okay, so you can see here, this is a base plate. So this part is a base plate. Okay, and you can see this is a base plate length, base plate width. Okay, and over that base plate, okay, so this is sorry, this is not base plate, this is a base plate. Okay, this is not base plate, I'll repeat once again. Okay, so here we can see this is a base plate. Okay, this is a base plate, and this is a width of base plate and length of base plate, width of base plate, and here you can see the thickness of base plate, and that base plate is resting on this concrete pedestal. That base plate is resting on the concrete pedestal. Okay, so ultimately what happen, whatever the load transferred through this column will be carried by safely, or it will transfer to the base plate, and through this base plate it will transfer to the concrete pedestal. Okay, understood. So this is a overall picture of the how the load transfer from base plate to the concrete pedestal. So we will discuss about the types, that is slab base and gazetted base. Okay, so first is slab base. Slab base are used where the columns have independent concrete pedestal and a thick steel base plate and two clit angles connecting the flange of the column to the base plate. So we can see here, here also you can see. Okay, here it's a column and a column flange is connected with the angle. You can see the angle, the column flange is connected with the angle. Here in plan also you can see, in plan also you can see here. Okay, here also you can see. Okay, so here also the angles are connected here in plan, you can see, and these are the flanges of the I section. Okay, so in plan you can see, and even you can see in the elevation, cross section elevation, and this is a base plate. I can show you the base plate here. Okay, so this is a base plate, so this is a base plate, and below that base plate we have the concrete pedestal. So this is a concrete pedestal. So column, when what is a when you call it it is a slab base, you can see it is a simple connection. You can see it is a simple connection provided with, it is a simple connection provided with a two clit angles side by side. Okay, one on this side and one on this side. I can show you once again. I can show you. So you can see two angles, clit angles connected to the flange of column. Okay, and a base plate here you can see. So it's a simple connection connected with base plate along with two clit angles. Sometimes, okay, sometimes in addition to these, web clit are provided to connect the web of the column to the base plate. These web clit guard against the possible dislocation of the column during erection. So we have seen just here, we have seen, I'll show you in the 3D part also. So these are clit angles which are connected to flanges. So ये है हमारा flange. Okay, so these are the web clit connected to the flange. Okay, along with that we have additional, यहाँ पे देखो, we have one more additional angle which is called as web clit, which is called as web clit, which is called as web clit. Okay, which is mentioned here in the explanation. Okay, which is mentioned in the here in the explanation. In addition to these, web clits are provided to connect the web of the column to the base plate. So I can explain. So this is a web and this angle is connected to the web of column to the base plate. Okay, which is mentioned here, web of column, which is mentioned here, web of column to the base plate. So you can see this is a angle connected to the web of column to the base plate. Understood? Then these web clit guard against the possible dislocation of the column during erection. The next point is the ends of the column and also the base plate should be mechanized so that the column load is wholly transferred to the base plate. So mechanized means, so it should be properly connected. The column, web clit angle, I can show here, the column, then the web clit angle, then the flange angle and the base plate. All together it should be mechanized so that the whatever the load coming from the column should be transferred safely to the base plate. Okay. So next is gazetted base. So here you can see the picture of gazetted base. Gazetted base are provided for columns carrying heavier loads requiring large base plate. So when you provide gazetted base, when the column carry heavy load, when the column carry heavier load, and then a gazetted base consists of a base of a reduced thickness and two gazetted plates are attached one to each flange of the column. So what they are given, a gazetted base consists of a base of reduced thickness and two gazette plates. So means two gazette plates attached. You can see here in the previous and this, what is the difference? This is the difference. Here this is the difference. Here we have additional two plates. Here we have two additional plates which are called as gazette plate. So in gazetted base there will be addition of gazette plate on each side of the flange. So this is nothing but the gazette plate which is connected to the flange of the angles to reduce the thickness of base plate. Okay, so we will continue. Then next is when the load on the column section is too large, or I will repeat once again, when the load on the column section is too large, or when the axial load is accompanied, this is very important, the axial load along with bending moment, usually a gazette base is provided. So when we have to go for gazette base, first of all, if the load is very heavy in the column. Second is when a column load is accompanied, or a column carrying axial load plus bending moment, we have to go for gazetted base only. So in case of slab base, we have to design slab base only when the column subjected to axial load. But in case of gazetted base, we have to design when the column is subjected to axial load plus bending moment. So axial load should, again it will be very heavy. Okay, so gazetted base is provided. A gazetted base consists of base plate of reduced thickness, two gazette plate and clit hanger are placed on column flanges. So I will explain here. You can see here. Here we have, this is column, and over that column two gazette plates are connected. Then again for that there is a clit angle here. You can see this is a purple color angle, clit angle on both the side of the flange. This is a cross sectional view, and you can see here this is 3D view. This purple color is nothing but the angle, this clit angle, and over that this part is again is what? Gazette plate. Okay, so here again see, there is first there is a column flange, second we have gazette plate, and third we have clit angle. See how the assembly is. We have column and a flange. To that flange a plate is attached which is called as gazette plate. Again to that plate a clit angle is attached. Okay, so there are, the assembly is for three elements. One is the column with flange, and to the flange a plate is attached, and to that plate the angles are attached on both the sides. Okay, so how you get the dimensions of base plate? Then parallel to the web. Okay, parallel to the web means, see, dimensions of base plate parallel to the web. So that is first depth of section, means what is the depth of section? Then 2 times the thickness of gazette plate and 2 times the thickness of 2 times the thickness of leg length of angle plus overhang. Okay, so that is first is depth, then the thickness of gazette plate, then the leg length of angle, then the overhang portion. So that will be the total length of gazette plate. That will be the total length of gazette plate. Okay, understood? The next part is steps for design of slab base. So we will just go through what are the steps required for design of slab base and gazetted base. So what is the step 1? assume suitable grade of concrete. If the grade of concrete is not given, you can assume the suitable grade of concrete. Considering uniform stress at the bottom of plate. So what is this uniform stress? So as the column load is transferred through base plate to the concrete pedestal, so the concrete pedestal will react in opposite direction. Suppose the load acting from the column is vertically downwards, and that will be transferred through the base plate vertically downward. So concrete has to react from the opposite direction. So that's why the grade of concrete is very important, and that concrete will develop a uniform pressure from bottom side. This is the same as what we have done in design of footing. Okay, considering uniform stress at the bottom of plate, the bearing strength of concrete determines 0.45 FCK. So we have to take the bearing strength, like in design of footing we used to use safe bearing capacity of soil. So here you have to use safe bearing capacity of concrete, because the pedestal is made up of concrete and over that the base plate is resting. So that base plate has to transfer the load to the concrete pedestal, means you have to take the bearing capacity of concrete, so which is taken as 0.45 FCK. Step 2, the area of slab base may be computed by force by bearing pressure. So as we have done in design of footing, how you get area in design of footing? Load divided by SBC. So here also load divided by bearing capacity of concrete. So where P is factored axial load on the column. So what? The P is given as load acting on the column. Then step 3 is select the size of base plate. You have to select the size of base plate. For economy, as far as possible, kept the projection A and B equal. So I will explain this while when I solve the problem, what is A and what is B and what is their offset. Okay. So therefore the W is equal to, so after getting the size of plate, so you want to find out the W, so P divided by area of base plate. So you can easily find out that. What is step 4? The intensity of pressure W from the pedestal is determined by, so you have to find out the intensity of upward pressure. So that is P divided by area of base plate provided. So what area we have assumed? Based on that we have to find out what is the upward pressure below the base plate. So from that we can find out the intensity of pressure. So from that we can easily find out what is the intensity of pressure from the concrete pedestal. Okay. So step 5. So ultimately what will happen here? If the intensity of pressure developed below the foundation is less than the bearing pressure of concrete, your concrete capacity will remain safe. Okay. Then step 5. Then you have to find out what is the thickness of, after getting the area, next is thickness. What is the thickness of base plate required? So that is step 5. The minimum thickness required as per, you have to go for this clause as per IS 800-2007, and from that you can easily get what is T. What is T? Means what is the thickness of plate or what is the thickness of base plate. That should be, you have to check here, that should be more than TF. Whatever the thickness of base plate you will get, that should be more than thickness of base plate. Okay. So over where, what is the thickness of base plate now? The thickness of base plate should be more than TF. So what is TF? TF is nothing but here. So TF is nothing but here flange thickness of compression member. Means your base plate thickness should be more than the flange thickness of the compression member. So this is the ultimate. Okay. Then next we have the steps for design of gazetted base. The design of gazetted base. So what is step 1? Again the step 1 remains same. Even the step 2 remains also same. Step 3 also remains same. Uske baad next is we have to find out the step 3. The size of gazette plate is assumed. Okay, you have to assume the size of gazette plate. So how we can assume? The gazette plate should not be less than 16 mm in thickness for bolted gazette base. the size of gazette plate should not be less than 16 mm, that is the first. Then the thickness of clit angle is kept approximately equal to the thickness of gazette plate. Means if you are assuming the gazette plate thickness as 16, you keep the thickness of clit angle, you choose the angle such a way that it should be same. Then next is the length of gazette material is normally kept equal to the length of the base plate. So the length of gazette material is normally kept equal to the length of base plate. Understood? So means the length of the gazette plate, you have to keep it equal to the length of base plate, parallel to the flange of the column. For welded gazette plate, clit angle will not be required. So if you are using the welded gazette plate, then the clit angle, the necessity of clit angle is not required. Okay, so this is regarding the overview of column basis, and basically there are two types, slab base and gazetted base. So we have discussed about the difference between slab base and gazetted base also. Okay, so you can go through this, and when we solve the problems you can actually get to know what is the difference in slab base and gazetted base. So if you have any queries, you can discuss, and you can message me or you can call me. Okay, thank you, bye bye.